So I will explain how the system works end-to-end, starting from the user query all the way to backend processing. Let's start by looking at this architecture diagram. The system has 5 main parts: user query and input handling, online processing to handle real-time response, offline processing for document indexing and preparation, data storage and caching with Cosmos DB, integration with Azure AI services like OpenAI and Azure cognitive search. I will break each of these down for you. So for user query and input, users send queries through the interface. This could be a online web chat. The servers is a first stop. It checks whether we can use the catch result to speed up the response. The query goes to Cosmos DB, where the system checks if the query or something semantically similar have already been processed. If the catch is a hit, we quickly return the catch result. If the catch is a miss, the query is processed through the full retrieval and generation pipeline. It's important because this catching reduces repeated processing of similar queries, making the system faster and more efficient. Where there is no catch hit, the query goes to Azure Cognitive Search, which performs a semantic search. That's online processing. Involves finding the most relevant document chunks using embeddings generated during offline processing. The retrieved chunks are passed to Azure OpenAI, fit into the prompt template together with user query, and the LLMs generates the final response. So why we choose those tools? Because Azure Cognitive Search is excellent for fast and accurate semantic and keyword-based searches. And Azure OpenAI, such as GPT-4, can generate high-quality natural language responses. Offline processing is where all the heavy preparation work happens. This ensures the system has everything it needs to handle queries efficiently in real time. And document intelligent for document intelligent, we use Azure AI Document Intelligence to process various document types like PDF, Words, and TXT files, and so on. It extracts structured data like labels, headings, and paragraphs. The documents are break into smaller, meaningful chunks, making them easier to retrieve during queries. Because the better chunking strategy you use, the higher a recall you have when you're doing the retrieval process. And each chunk is converted into embeddings. These are semantic vectors that represent the meaning of the text, and the embeddings and the metadata are stored in Azure Cognitive Search, creating an index for future queries. And for data storage and monitoring, we use Cosmos DB. Cosmos DB is where all embeddings, metadata, and cache are stored. It's optimized for fast reads and writes, making it ideal for this system. It's a high-performance, globally distributed database that works perfectly for catching and storing embeddings. Also, we can use Azure Monitor. This tool monitors system performance. For example, it tracks catch hit rates, query response time, and errors, helping us identify and fix issues quickly. So that's a overview of this system.